will be. Yeah, in today's topic, we are going to talk about the distributed consensus when there is a crash fault. That means the behavior of the node is okay, the computer or the machine is okay, but due to the hardware problem or anything, if there is a crash, then how the agreements will be taken place among the miners that we'll try to discuss. So the basic objective is we need to, for the distributed consensus, then the faults in the distributed consensus, okay, which we already discussed, but just need to recall them. So what is the need for distributed consensus means? In case of the multiple decision makers means in case of there are multiple miners and they collectively work on creating the new blocks and validating the new blocks, they want to come to certain decision, and then we require a consensus algorithm for them, so which we already discussed in our previous lecture session. So in this distributed consensus, that helps to reach an agreement in the case of distributed computing, where they are going to compute the difficulty, or we call the proof of work or proof of stake or proof of burn or proof of deposit mechanism. Okay. So different mechanisms are there. But in the case of suppose state machine replication, where the small code that will be executed by every machine, that will happen in the permissioned model we will discuss in the next. So we replicate the common status so that all the processes have the same view of the state. But in the faults in the distributed system, as we mentioned, that crash faults. That means the nodes stop operating or stop responding the network. So that happens either because of the hardware or the software faults. And we also looked at this distributed network operated in two different ways. One is in synchronous way and asynchronous way. But in an asynchronous system, to do not know whether message have been delayed or the node is not responding, that happens. So the rely on majority voting in these faults of distributed systems, that is the progress as and when a node received the confirmation from the majority of the miners in the network. So the propagation of the consensus information, that means every node which are known as the miner, the node on the slow network will receive it eventually. Correct? And another problem which we identified in distributed system is Byzantine faults. That means the node misbehavior. So which we already discussed this. Okay. This is sometimes more difficult to handle, but we discussed how to handle them based on the block size and the valid consensus. Okay, and we have seen some of the security issues also about this Byzantine problem, which we addressed in the previous one. But in asynchronous network, the distributed system, then how to reach to a consensus when a node is crashed or fall because of the software problem or hardware problem. If the node is disconnected from the network, then how to handle that? So we have seen the FLP impossibility, that giving priority to the safety over the liveness. So in this case, in the consensus with this crash fault, assume there are three nodes, P1, P2, and P3. And These three nodes are in the peer-to-peer distributed network. And during the operations, suppose the P3 node is crashed, for example. Okay. So when the P3 node is crashed, then how they reach to the consensus? So in the crash faulty consensus, I will say that consensus with the faulty tolerance, the first one is guarantees the validity. So to guarantee the validity, that can be explained using this graph. The consensus algorithm assumes there are a number of the processes or the machines which are connected in the network. So every machine, whenever a new process is created, it gives a value. Okay. If all correct processes the same value, suppose like the P1 processor given a approval that proceeds, suppose the V1. So then it will receive the value, suppose the D1 which is created by another node that proceeds. So two operations will be take place. One is the proposal, second one is the acceptance one. So each processes in this network, they are first goes through the undecided state after getting the processes from others. They first go to the undecided state, that is the proposed value V1 from the set D, from the domain. Then next they go through the communication state. They exchange these values, the V1, like V2, and then they go through the decided state that set the decision variable like DI, the decided states. So in this case, the validity is if all correct processes have the same value support. Okay, if P1, P2, P3, all the nodes, the processes, if they have the same value V, then any correct process decides the V, the decided state. So unlikely to happen in proof of work. So the next one is agreement among all these nodes. So the agreement among all these nodes is there is no two correct processes decide differently. That is like safety, that is not in proof of work. And the third one is the termination one. So in termination, as we know that once the block is confirmed and that is added to the blockchain, then the process eventually stops. The same way, in this asynchronous consensus with this crash faults, every correct process eventually decides to go with the agreement and they stop executing that one. So this is the liveness in the priority. Okay, so in this, if you observe the consensus faulted, sorry, in the CFT consensus with the crash faults, we looked at the Paxos and Raptors, but here in this case, with this crash faults, how these Paxos consensus protocols works, that we'll try to explore. Okay. So the first in this consensus to talk about this, let's assume there are 5 machines in the network. Okay, let us say machine 1, 2, 3, 4, and 5 machines are 5 systems in the network. And this network is a asynchronous network. But first, let us assume that if every node are connected in the synchronous network means every broadcasted process reach to every other node in synchronous system. So then what is the first one? First, every a node or machine try to propose, whatever their ideas suppose. So let's go for a dinner. And assume that another node, okay, the another node perform that let's go. That means during that in synchronous one, this message is going to every node in the network, and then everyone is sending a response back in the network that deciding the state. This one is the process state. So in the deciding state, every other node, they given the reply. But in this, assume that because of a hardware or software issue, assume that this machine or this node is not operated. That means this machine doesn't know that which process is going on and what is the desired state. So then how to reach to the consensus? The same concept is majority of. So out of 5 nodes, majority of nodes, okay, they agreed with this process. So when majority of nodes agreed, that achieves or reach the consensus. Okay. So majority agreed. So perfect consensus is there here. Correct? Isn't it? And they all decided to go with the process, let's go for the dinner. But later on, when this faulty node, when it is the crash faulty node, when it is become active and connected to the network, okay, they don't know that which process is going on and state is going on. So in that case, whatever the proposal is there, let's go for dinner. This one first node is also agreed, and second node says I'm okay. Another node also said let's go for a movie. Another proposal, second proposal. So then when all the nodes are active, okay, if there are no faulty nodes, then how to reach to the consensus? So there are two proposals, proposal 1 and proposal 2. Proposal 2 from these two nodes. Proposal 2 from these two nodes. So this node 3 says movie is a great idea, but these two nodes, let's say node 4 and node 5, they are agreed with this proposal. Okay. So then how to reach the idea? So then assume that this node, the third node, the next receiving upon this movie is a great idea. Okay. So then the remaining nodes, they may change their opinion. So this can happen when all are in this synchronous system, because the message is not delaying, right? So how many, to get the consensus, it gives how many people can be sleeping at a given time. So at a given time too, how many are sleeping means when this is proposed, how many are sleeping means this node is also sleeping. Okay, this node is also sleeping. That means they are not active, for example. Okay, so that gives okay with movie 2, we also agreeing. So how many nodes are sleeping here means? So we are going for a dinner, right? That means no idea. Then the second one is saying, so no dude, we decided for movie. So how many nodes are sleeping here means this node is sleeping. So says that, may not like, but there is the only option for me. So then how many people can be sleeping at a time in this? How many are sleeping? By observing this animation, if you recall, this proposal, that time this user is sleeping, later on they also agreed. So at a given period of time, how many are sleeping means 2. So that means from this particular concept in the asynchronous system, you can derive that if there are F faulty nodes at a given time period, F faulty machines are the crash fault, we need at least the active nodes that are 2F plus 1. So if you take the previous example out of 5, if there is one faulty node at a given period of time, then at least 2 plus 1 nodes must be active to reach the consensus. Okay, so out of 5, if 2 are sleeping, then 3 must be active. So by applying this concept, the CFT consensus mechanism in the asynchronous CFT, this is the standard process to reach to the consensus.